Hello, today we are going to take another look at question 11, container with most water. In the last video, I have introduced a straightforward solution for this problem, which is we set up two pointers and we calculate every possible area, and then we find out the maximum one among them. And today we are going to take a look at this solution to find out how can we improve from there. So first thing, in the previous solution, the pointer we get is going to one direction, which generates a lot of duplicates, a lot of meaningless possibilities, which we can easily improve. Is we can set a pointer, the first pointer at the beginning and the second pointer at the end. The first pointer from left to right, the second pointer from right to left, and when they meet we have already calculated all the possibilities. So the only difficulty we have to solve is that we need to set up rules for how we move those pointers. So by observing the pattern we will find out. For example, this area is determined by this and this. This length is only one variable, but this height we can get two height, L1 and L2. And to illustrate my idea, I have to introduce another height, which is height V. Height V is valid height. So how we get the valid height? So the valid height in these problems is the smaller height between these two. Therefore, we find out a very important rule, that is, it is pointless to move the pointer on the bigger height. Why is that? Because moving the pointer on the bigger height won't change the valid height, because the valid height is not determined by the bigger height. The only possibility the valid height will get updated after we move a bigger height is when the pointer is on a even smaller height. So that of course will make the area even smaller, but the best case is that we keep the current valid height and we just reduced the length because we moved the pointer. Therefore, basically we don't have to move the pointer on the bigger height. So when we get this idea, then we can set up the rules of how those two pointers can move. Now let's see how can we code this idea. So to code this idea, I need two pointer A, which is from the start of the array, and pointer B, which is at the end of the array. So it's height length minus 1. And of course we still need our maximum area variable to update. We need to keep it updating, and then we return the maximum area. So this way we use a while loop. This while loop will keep going if pointer A and pointer B haven't met each other, and first we get the current area of from pointer A and pointer B, which is mass of absolute value of pointer so the distance between pointer B and pointer A multiply mass of the minimum value of the height of pointer A and height of pointer B. Then we compare it with our max, which is quite the same as the previous solution, this part. So if current area is bigger than max, then the max gets updated to current area. Then we need to set up the rules of how do we change the pointer, which is if height of pointer, we always change the smaller height, the pointer on the smaller height. So we move in this case we move the pointer A, else we move the pointer B, then we return the maximum area. Okay. Yeah, so you can see the runtime is much faster, and let's take a look at the time complexity. So in the previous solution, the time complexity is O of n squared, and this solution, the time complexity, we managed to reduce it to O of n, because we by doing this way, so this is like one pass from left to right, two pointer, one pass, and we have a clear rule of how we move the pointer. So we reduced a huge amount of meaningless area. Why those areas meaningless? Because they are definitely not the max area. They're definitely smaller than some area in the area we are considering. So the most important, I think the key of this solution is that we have to observe this pattern and find out it is meaningless to move the pointer on the bigger height, because the height, the valid height is determined by the smaller height. So move the bigger height won't change anything. Will only make the area smaller. That's the key point. So once we get the key point, then we can make this solution.